Welcome everybody. Today I will tell precautions to be taken in op-amp electronic circuits. But you can use precaution in other digital electronic circuit also. This I am telling based on my long experience in designing the electronic circuit boards. First is this. This is op-amp I have shown. We should use one capacitor 0.01 microfarad, both sides, in plus also, minus also. This is high frequency capacitor. It can be metallized polyester. This capacitor should be used each for all ICs. If you are using 10 ICs, you have to use 10 number of this capacitor. These capacitors are not common for the board. Then we must use electrolytic capacitor, here also, here also. This capacitor electrolytic 10 micro is common for a group of ICs. Say for 4 IC, we can use one common. For every 4, you can use one. Here you see, I have connected reverse. This positive terminal is grounded and negative is connected to negative, such that voltage across capacitor remains positive. Electrolytic capacitor cannot take reverse voltage. Here, in lab, college lab, you get regulated power supply. But in the house, power supply is not regulated. We depend upon the rectifier and the transformer. If it is battery, then it may be okay. But if it is from 220 volt, it is not regulated. Then we should use 1000 microfarad electrolytic capacitor. This one is sufficient for entire circuit. If you are using 10 IC, still one will do. Then there are two methods of using IC. In one method, we give input to positive and negative is grounded. In another method, we give input to negative terminal, positive is grounded. This method is not good. Whenever I have used this method in my projects, industrial projects, this has created problem. This is working fine always. So please give input to negative. If you want further inversion, use one more IC. This should be avoided up to extent possible. Then this is power supply arrangement. This is common for whole board. If you are using 10 IC, this is common and to be used at input. This is 2 diode 4007. These are 2 electrolytic capacitors. This is different, this is different. This is for a group of IC. This is common for entire board. You have to use both. This is metallized polyester 0.01 microfarad capacitor and this is electrolytic capacitor 10 micro. What happens? Many times I have seen that IC will fail. Generally mistake will be, we give reverse voltage, we give positive here, negative here. This diode will protect this PCB from reverse voltage. It will short circuit and IC is protected. In my all module I am using this. If somebody gives wrong connection, then also the circuit is protected. This is very important and this costs very less. Then this is IC. We are using so many resistor. Resistor value should be in this range. It should be more than 1K, less than 47K. What happens when they make resistor higher value? They reduce the thickness of resistor. With that method, we achieve the higher value of resistor. Though higher the resistor value, thinner the resistor will be. Will not go from outside, but inside will be thin. And it can break very easily. So higher value resistance should be avoided, except hysteresis resistance, which is used between plus and this, that you cannot reduce because that is always higher value. But for all other possible resistor values, use less than this. And higher value is very sensitive for noise also. This will lower value using resistor will help noise protection also, and resistance value should not be very low also. Then this IC, even many IC has output short circuit protection. We should not drive capacitor directly. This should be avoided. You have to put some resistor. Then between negative terminal and positive terminal, we should use 1.001 micro. This is 1 nanofarad capacitor. Small ceramic capacitor you can use. This improves instability. This should not be connected between this and this. Positive terminal and output, if you connect, stability problem will increase. You have to connect between output and negative terminal. Then here, two diodes are shown. These are signal diode and are used in anti-parallel way. Here cathode is up, here cathode is down. I have used 1N4148. You can use any other signal diode which has speed. This will protect the IC from over voltage between these two terminals. All IC in lab you may avoid, but in PCB assembly you should use it. Lab also it is better. If you do the mistake, give more differential voltage, then IC will fail. Put this. Now here is IC, this plus terminal and minus terminal. Do not touch. No CRO or multimeter should be connected here. Because once you connect here, there will be lengthy wire. That lengthy wire will pick up lot of noise. That will create lot of disturbance. Don't touch it until otherwise it is necessary to measure the voltage here. Otherwise don't connect to anything. Don't touch it. Actually no component should be touched by hand. Body has some capacitance. Because of capacitance, noise may come. Component may fail. Please avoid this. Then here I have shown one diode. It can be resistor also. When the current flows in diode or resistor, it gets heated up. To cool it down, manufacturer depends that heat should flow. It should go to PCB track. Manufacturer of the diode and resistor are depending on the PCB track for cooling. PCB track is used for cooling of this component. They also specify what maximum length it should be. To keep this lead length short, otherwise this component will fail. A short length will help in better cooling. Then in lab or house, the resistor and capacitor will be just lying. Lot of dust will come. So before using, you must clean that dust. You can take a knife like this. Suppose this is resistor lead. Do like this. It can be cleaned. This will help in improved contact between this terminal and the board, whether you are using breadboard or PCB. In both cases, this should be cleaned both sides. Even you are using new component, still you must clean it, because you might have seen they will put resistor and capacitor in a pack that is using some gum, some kind of gum, to keep so many resistors together in a strip. To remove that gum, you must clean both sides, resistor, capacitor, diode, whatever component, even IC with the lead, not chip type. Chip type there is no lead, it is very small terminal. Wherever possible, you should clean this leads using a knife. Now here there is a resistance. Because of current, it will heat up. Now what happens? There will be a component nearby. because of this heat, that component will fail. I have suffered in my some models, some PCBs. You will think that component is the problem, but problem is this resistor. So keep gap. Because of this heat, that will heat up and that will fail, because that cannot take heat. Then I have shown a potentiometer. Potentiometer has lot of surface area. Whenever anything has surface area, it has a capacitance. It receives the noise. To reduce this problem, keep size of this component small. Size doesn't mean value. Value will be whatever your design value. I am telling physical size, physically small. You will get small size and big size. Whatever small possible is there, you use that to avoid the noise problem. It will help you a lot. This may be picking up noise, you may not know. Then this I have seen breadboard. Breadboard, what happens? These are holes. These holes are short and connected with a copper strip. So between every row or column, there is a copper strip. Now when there are two copper strips, there will be capacitance. It is a small capacitor, but capacitance is there. You must know. In some circuit, this capacitor is not allowed. If it is allowed, very good, it will work. If it is not allowed, you cannot use breadboard. You have to assemble on PCB. So I have written, if C not allowed, this is small c between this and this, it may be in picofarad. Then use PCB. This is for your knowledge and information. When we switch on power supply, please wait say 60 seconds. When you switch on, the current will flow and voltage is applied across component, especially ICs. They require some time to stabilize because components get heated up. For example, transistor gain depends upon the temperature. Temperature, it takes some time because temperature will go up, it may take some 10 seconds, 20 seconds, so beta will change. So please wait 60 seconds. When component stabilizes, then you can carry on. Then margin for lack of knowledge. We think we are knowledgeable 100%, when nobody is like this. Everybody has some lack of knowledge, even I have. So we should give margin for that. I will talk this again here. 2 times I have written this especially. If you are designing for 5 watt, make it 6 watt. If you are assuming your design value is 0.1 ampere, make it 0.12 ampere. This is called the margin for lack of knowledge. Don't assume you know 100% or I know 100%. Then earth wire, thick earth wire we should use. If you don't have thick wire, you can use 2 thin wire or 3 thin wire. That also will do. You might have seen when you buy some electronic modules, you open that, say transistor, radio or something, you will see all empty area, they will put some copper layer. That is nothing but a thick earth. This helps to reduce the noise pickup. Now give margin for. We should give margin for design. First is knowledge gap. I have talked about here. We have some knowledge gap. We don't have 100% knowledge. It doesn't mean that we cannot do. We can do, but we should give some margin. Then information gap. Generally information we are getting may not be 100% accurate. Then we should give some design margin for that also. Then component tolerance. For example, some resistor is there. You have calculated value 0.1 ampere. Now suppose that component had tolerance resistor and is 5% less. Then this current will increase by 5%. So we must know that. Component tolerance, worst case design should be done. Better life. If you give more margin, life will be more. For example, in a 10 ampere inductor, if you play only 8 ampere, or design is 10 ampere, life will be better, cooling will be better. So we give margin for better life also. By giving more margin, life of anything can be increased. Better reliability. The more margin you will give, reliability will be better. It will not fail, it will not stop halfway. Generally our margin will not be there and component value will be so tight, a small variation anywhere will make module or circuit not working. So please give margin for that also. Then bad quality of components. What component you are buying, that quality may be bad. For example, the diode, 4007, it is written 1 ampere. But when you buy from the market, you don't know who has supplied. You are not testing also. You are not sending your component to some quality lab. It may work only up to 0.8 ampere. So please give margin for bad quality of component also. Generally, hobby project component which you buy from the market, their quality is not that good. Now give margin for environment. What is this? Suppose you are testing some circuit somewhere where it is AC or area is cold. It will work. But you go some other city where temperature is 45 degree, 48 degree, it is reaching 50 plus also in many cities, then circuit will fail. So because of this environment variations, you must give some margin. Because this same module or same circuit should work in every city, not only in your air conditioned lab or only in your house, it should work outside also. Then power supply variation. Generally power supply will not be stable, lot of variation will be there, even regulated will have some variation. So give margin for that. For example, suppose in catalog it is written, this IC will work up to maximum of 10 volt. Then don't use 10 volt, use only 8 volt. Then dust, lot of dust will come. You have to give margin for that. Then design mistake. We may do some design mistake. For example, I will tell what is common design mistake. All components have leads. These leads have inductor and capacitor both, but we always ignore that. Except communication engineers, in normal design we don't consider here in breadboard there is a capacitance. When we mount the component, between one component and another component there will be capacitance if size is big. This we don't consider. In most of the cases we don't consider. These are called the design mistake. So we should know that and keep some margin. My experience is give 50% margin in VIP. The voltage margin, current margin, power margin. Voltage means if you have to design some circuit from 100 volt to 200 volt, design for 50 volt to 400 volt, like that. 200 volt will become 300, you give for higher voltage. Similarly current, if you have to design for 1 ampere, design it for 1.5 ampere, give 50% margin, use thicker copper wire. Similarly power, if you want to make something for 100 watt, make it for 150 watt. More the margin is, better life, better reliability, better functionality you will get. This all I have told based on my experience. If you have the experience, no problem, you can use the value you want. But if you don't have the experience, this may be starting point and you can change based on your experience. If I am able to give you some knowledge and you like my tutorial, then please subscribe and press the like button.